All right, we are jumping into the next unit. We are in section 5.1. It says we have graduated from only looking at the most basic polygons, triangles, and now moving on to figures with one more side. Woohoo! It says below are definitions of each type of figure that we'll be studying. Only based on the definition, note all of the names that meet the characteristics of each figure. Inside the figure, write the most specific name for each object. In this activity, if sides look to be parallel, then they are. Usually we don't go based off of looks, but on this part of this activity, we are going to say if they look parallel, then they are. So we have the following. A quadrilateral is going to be a polygon with four sides. A parallelogram is a four-sided figure with two pairs of opposite parallel sides. Rhombus is a four-sided with all congruent sides, supposed to say four-sided polygon. Rectangle is a four-sided polygon figure with all right angles. Square is going to be a four-sided figure with all congruent sides and all right angles. And a kite is going to be a four-sided figure with two pairs of congruent and non-parallel sides. Trapezoid is going to be a quadrilateral that has exactly one pair of parallel sides. An isosceles trapezoid is going to be a quadrilateral that has exactly one pair of parallel sides and two non-parallel sides. Now in there, when I kept saying figure, it should say polygon. So like on rhombus, it says or on rectangle, it says a four-sided figure. It would be better if it said a four-sided polygon. So when we look at this, that first one looks to be a quadrilateral. It follows that it has four sides, a polygon with four sides, and it is also both opposite sides being parallel. So it's a parallelogram. And the most specific name for this is going to be parallelogram. The next one has four sides, a polygon with four sides. That's a quadrilateral. The next one would be a quadrilateral, a rectangle because it has right angles, a rhombus because all sides are congruent, a parallelogram because both opposite sides are parallel, and a square because it has a right angle and all congruent sides. So all right angles and all congruent sides. The next one would be a four-sided polygon, so it's a quadrilateral, and only one pair of opposite sides are parallel and the other ones are congruent. So that would be an isotrap, and is also going to be a normal trap. The next one would be a rectangle, um, and the subnames for it would be quadrilateral, parallelogram, and rectangle. The next one is a four-sided figure, so it's a quadrilateral, and it's also going to be a kite. The next one has four sides, so it's going to be a quadrilateral, and it is going to have one pair of opposite sides being parallel, so it's a trapezoid, and it is not going to be an isosceles trapezoid because the other two sides are not congruent. And the last one has four sides, and it's a polygon, so it is going to be a quadrilateral. Both opposite sides are parallel, parallelogram, and all sides congruent, rhombus. So as always happens when I make my keys and I start recording the video, I see that the keys have maybe one or two mistakes. So that top right one, it looks like I accidentally left out trapezoid. So it is a quadrilateral, trapezoid, and isosceles trapezoid. Now on the next part, it says, which figure has the most definitions? And that'd be a square. Why does this figure have so many definitions? It is the most specific of all of the quadrilaterals that we're going to be focusing on. And every figure can technically be classified as what? Well, they all have four sides and they're polygons, so they're all going to be quadrilaterals. Now in here it says in the previous section we found that certain figures qualify to be called different names. We are going to attempt to note which categories each figure fits into. Use the Venn diagram to the left to create another diagram categorized square, quadrilateral, rectangle, parallelogram, rhombus, kite, trap, and isotrap. Now, if you look at the one on the left, it says the most broad name for all these would be mammals. Then you could have a dog. A special type of dog is a lab. A special type of dog is a poodle. And a lab that's a poodle is a labradoodle. Now, a different type of mammal would be a cat. And then another type of mammal would be a rodent. And a specific rodent would be a gerbil. So you guys are supposed to be getting the different terms. Once again, it's square, quadrilateral, rectangle, parallelogram, rhombus, and then it doesn't say it here, but kite, trap, and isotrap, and try to figure out where they go. And they all fall inside of four-sided polygons, so they're all going to be quadrilaterals. Then we focus on parallelograms. Parallelograms, both opposite sides being parallel. Inside there, if it has a right angle, it's called a rectangle. If it has all sides congruent, it's called a rhombus. And if it has right angles and all sides congruent, then it's called a square. So you can see how I did the parallelogram aspect. On the right-hand side, if it has no parallel sides, then it's going to be called a kite. If it has one pair of parallel sides, it's a trap. And if it is a trap that has the other two sides that are going to be congruent, it's called an isotrap. Hopefully that made sense. Now next says below are examples of concave and convex polygons. Based on the examples, what does concave and convex mean? So it looks like one of them has a cave and one of them doesn't have a cave. So if it has a cave, it's called concave. If it does not have a cave, it's called convex. That is the easy way to come up with a way of distinguishing between the two. The better way is saying between any 2 points, the line segment that's created cannot fall outside if it is convex, and it can fall outside if it's concave. As you guys can see, there are 2 points where the line segment would fall outside. It wouldn't be on the side of the figure, and it would not be inside the figure. So it falls outside, and that one would be called concave. So our quick notes are quadrilaterals can be classified by what characteristics they have. See the diagram above that kind of explains that while some figures have a most specific name, they can be classified by other less specific names. For example, a square could also be a rhombus, rectangle, could be a quadrilateral, could be a polygon, and could be a shape. But you're most likely going to call it by the most specific name, which is going to be a square. And then we have the difference between concave and convex. Hopefully that makes sense. Now let's go ahead and check your understanding. It says give the most specific name for the following quadrilaterals. A quad that has right angles would be a rectangle. A quad that has both opposite sides being parallel would be a parallelogram. A quadrilateral that has 4 right angles and all congruent sides would be a square. A quadrilateral that has all congruent sides is a rhombus. Quadrilateral with opposite sides being one pair of opposite sides being parallel is a trapezoid, and this cannot push to being an isotrap because those other two sides are not congruent. The next one is a quadrilateral with all sides being congruent. That is going to be a kite. And the last one would be one pair of opposite sides are parallel, the other pair are going to be congruent, and that would be an isotrap. Now, the next one says, use the word sometimes, always, or never to complete the following. A square is how often going to be a rectangle? A lot of people have trouble with these. A square is a thing with all right angles and all congruent sides. How often does something with all right angles and all congruent sides have right angles? Always. The next one says, a four-sided figure with both opposite sides being parallel. How often does it have all sides congruent? Well, it's possible, but it's not guaranteed, so that'd be sometimes. A trapezoid is never going to be a rectangle because by definition a trapezoid can only have one pair of opposite parallel sides and a rectangle has to be a parallelogram, so that would be never. A rhombus is going to be a figure with all congruent sides. How often is that going to also have right angles? It's possible, but it's not guaranteed. So if that rhombus did have right angles, you're probably going to call it a square, but it's also called a rhombus. A four-sided figure with all congruent sides is always going to have 4 sides and be a polygon. So that's always. Next says, what is the most specific name for the following quadrilateral? Give a thorough explanation as to justify your answer. Now looking at this, it has 4 sides. It's going to be a quadrilateral. It looks like a rectangle, but the only way we could say it's a rectangle is if it has a right angle. And it looks like it has a 3, 4, 5 triangle inside of it. So that would mean that it is a right triangle, right angle, and therefore it is going to be a rectangle. Hopefully that made sense. Now for the homework, it says give all possible names to the following shapes based on only the markings and your understanding of the hierarchy of quadrilaterals. Circle the most specific name. Okay, and you have quad, parallelogram, rhombus, rectangle, square, trapezoid, isotrap, and kite. The first one, ignore the fact that all these look like squares. It only has one pair of opposite sides being parallel. So that one would be a quad because it has 4 sides and a trap. The next one has 4 sides, quad. Both opposite sides are parallel. How do I know that? Well, since we have those 2 right angles, the only way those angles could be both right would be if because it's basically SSIAs. SSIAs are supplementary. And if the SSIs are supplementary, then it's got to be parallel. So this would have 4 sides, quad, it's a parallelogram, and it's a rectangle. The next one has 4 sides, quad, opposite sides being parallel. How do I know that? Because it's right angle, they add up to be 180, so SSIAs are sup. That would be a parallelogram, has a right angle, rectangle, has all sides congruent, rhombus, and has right angles and all sides congruent. That's going to make it a square. The next one has one pair of opposite sides being parallel and the other sides being congruent. I left one answer out here. This should be quad, trap, and isotrap. The next one is going to be a quad. It's going to be a parallelogram and a rhombus as well. If it is going to be a rhombus, then it's got to be a parallelogram. The next one would be a kite, because you have 2 pairs of congruent sides, but they are not opposite one another, and this is by definition a kite. Kite is a 4-sided figure with 2 pairs of non-opposite congruent sides. The next one just has 4 sides, so it's going to be a quadrilateral. And the last one has 4 sides, quad, and 1 pair of opposite sides are parallel, trapezoid. Use the words sometimes, always, or never to complete the following sentences. A kite is never going to be a square, because a kite cannot have parallel sides, and a square has to have it. A parallelogram will sometimes be a square. That parallelogram might have right angles and all congruent sides, but it might not also. A square, a thing with right angles, all congruent sides, it's a parallelogram, is always going to be a rectangle, because it has right angles. An isosceles trapezoid is going to always have 4 sides, so it's always going to be a quadrilateral. A rectangle is always going to be a rhombus. The reason why is, oops, that is incorrect. I'm going to have to fix that on the key. A rectangle is a parallelogram with right angles. Is it possible that it has congruent sides? Yes. So that's supposed to say sometimes. So 2E is sometimes. The next one, draw an example of a concave polygon with 6 sides. You can see the one that I drew has a little cave in it. Yeah. And the next one says, what is the value of x such that this must be a rectangle? Well, that means that a squared plus b squared has to equal c squared. And if you do that, 10 squared, 24 squared, you get 26. And then x is half of it, so that is going to be a 13 and a 13. All right, hopefully that made sense. Glad I made the video so I could see what I needed to fix with the key. Sorry that that wasn't fixed by the time I made the video, though. Thanks for watching.